Unit. Today we are going to discuss paper 6, unit 19. Paper 6, unit 19. We discuss paper 6, unit 19. Paper 6, unit 19. That is chiral, auxiliary control, methods. Chiral auxiliary control methods. Chiral auxiliary control methods. That means first we are discussing chiral auxiliary. Okay. Chiral auxiliary. Chiral auxiliary is a pure chemical substance. Chiral auxiliary is a pure chemical substance which is temporarily attached to substrate, and give the direction for asymmetric synthesis. After completion of asymmetric synthesis, it is generates it in its own form. Okay, it generates in its own form. That is chiral auxiliary. Okay, we are discussing different chiral auxiliaries with some examples. Okay, first we are discussing one alkylation of chiral enolates. First one is alkylation of chiral enolates. Alkylation of chiral enolates. So we are taken that is chiral enolates. When we take this is S-proline. S-proline. When this S-proline reacting with lithium aluminum hydride undergo reduction of carboxylic acid, then produces alcohol. So now it is S2-hydroxy. S2-hydroxy. S2-hydroxy methyl pyrrolidine. S2-hydroxy methyl pyrrolidine. It is act as a chiral auxiliary. Okay, chiral auxiliary. So what is a chiral auxiliary? Chiral auxiliary are the chemically pure substance. Pure means chiral compounds, which is temporarily associates with substrates and give the direction of asymmetric synthesis. After completion of asymmetric synthesis, it is generates in its own form. Okay, so this is a chiral auxiliary. So our condition is when we take acetic anhydride in presence of this chiral auxiliary, by reacting with lithium diisopropylamide, then followed by methyl iodide, followed by hydrolysis. So the product is this is a product. Okay, R, this configuration is R2-methyl butanoic acid. R2-methyl butanoic acid is a product. Okay, so how to the formation of this compound means when we take this chiral auxiliary, when reacting with acetic anhydride, when we take acetic anhydride, so this is when nitrogen undergo replace this acetyl group, and this acetic acid will be removed, then forms C2H5, and this is alcohol. When this compound reacting with lithium disopropylamide. Base subtract the proton from here, then forms CH3 OET minus. That is Z enolate. Z chiral enolate. Z chiral enolate is the formation of product. Here hydrogen. When this compound reacting with methyl iodide, enolate is the source of alpha carbon anion. Here this is negative charge. This negative charge attack at methyl carbocation by leaving iodine. So the attacking of methylate this carbon from backside, because at front side this bulky group is there. Therefore, the methyl approaches to its carbon anion. This methyl carbocation approaches this carbon anion from backside, because corresponding here the bulky group is front side is therefore attacking from backside. Then that forms. Therefore, this hydrogen going to front side. That hydrogen going to front side, and methyl coming from back side, and ethyl group is on plane. And here this is a chiral. When this compound undergo hydrolysis, then forms our chiral auxiliary. This chiral auxiliary generate its own form. Then product formation takes place. Chiral product is the formation takes place. Hydrogen, methyl, C2H5. So this is the product. This forms about 84% of enantiomeric excess. Then it forms about 84% of enantiomeric excess. This is the alkylation by using chiral enolates. It is the chiral auxiliary. Okay, what I'm telling you, chiral auxiliaries are chemically pure substance which is temporarily associated to substrate. After completion, if they give this chiral auxiliary give the direction of asymmetric synthesis. After completion of the asymmetric synthesis, it generates in its own form. Okay, this is a chiral auxiliary alkylation of chiral enolate. Okay, they are going to discussing with next one is alkylation of chiral aza enolates. Next, we are going to discussing alkylation of chiral hydrogens and chiral imines. This is important. Whatever we are discussing, that is important. Alkylation of chiral hydrogen and chiral imines. Alkylation of chiral hydrogens and chiral imines. Okay, first one is alkylation of chiral hydrogens. Chiral hydrogens. Okay, so this is the compound. When we take a SAM or RAM with the chiral auxiliary. Okay, SAM and RAM are taken a chiral auxiliary. So that is one from alpha propylation of 2-pentanone. Alpha propylation of 2-pentanone. Okay, alpha propylation of 2-pentanone with the take chiral SAMP. SAMP is the chiral auxiliary. Okay, SAMP is the chiral auxiliary. When we take 2-pentanone, with SAMP is the chiral auxiliary. So by reacting with the lithium disopropylamide base, and we take N N-propyl iodide and N-propyl iodide, then followed by ozonolysis in presence of DCM solvent. Then the product is CH3 double bond O, NC3H7, C2H5 and hydrogen. They forms 62% of enantiomeric excess. Okay, here I am taken with some examples. When SAMP is reacting with 2-pentanone, SAMP is reacting with 2-pentanone, they forms imines are the product. Imines are the product. Imines are the product. When this compound reacting with the lithium diisopropylamide, base subtract the proton from here. Base subtract the proton from here. Then the forms NH N minus methyl hydrogen like this. In this compound, this is alpha azaenolate. This is alpha azaenolate. Azaenolate is a product. When this compound reacting with our C3H7 iodide, N-propyl iodide, when reacting with N-propyl iodide, so azaenolates negative charge. This azaenolates a source of alpha carbon ion. This alpha carbon ion reacting with carbocation from the backside, because here the bulky group is front side, therefore attacking from backside only. Then the product is methyl C3H7 C2H5. This is hydrogen. When after hydrolysis, ozonolysis, then forms so N-nitroso 2-methoxymethyl propidine, N-nitroso 2-methoxymethyl propidine, and the compound is C3H7 C2H5 hydrogen. Okay, then the product is, and when this compound undergo reaction with lithium aluminum hydride, then forms chiral auxiliary in its own form. Chiral auxiliary in its own form. Okay, this is the product. Next one is alpha propylation of 2-pentanone. So that's enough. Next one is alkylation of chiral imines. Alkylation of chiral imines with alpha, that is alpha methylation of cyclo Xenone. Alpha methylation of cyclohexanone. Cyclohexanone. When we take benzyl NH2 methoxy hydrogen. This is a chiral auxiliary. In this chiral auxiliary, when reacting with the cyclohexanone, then forms chiral imines. Then forms a chiral imine. This chiral imine methoxy and hydrogen. When this compound reacting with lithium disopropylamide, and the base abstract the proton from here, then a negative charge is the formation takes place. That negative charge undergo delocalization, then forms benzyl, here methoxymethyl, here hydrogen. Now here again you undergo reverse negative charge. This negative charge reacting with methyl iodide. This negative charge reacting with carbocation from backside. Then forms hydrogen is coming to front and methyl going to back, and N benzyl methoxymethyl hydrogen. When this compound after hydrolysis then forms alpha methylation of cyclohexanone is the product, and chiral auxiliary generates in its own form. This is a alkylation of chiral imines. Next, we are going to discuss very important Prelong's rules. Prelong's rules. This Prelong's rules applicable for 1,2 asymmetric induction. 1,2, 1,4 asymmetric induction. Prelong's rule applicable for 1,4 asymmetric induction. So that means new chiral center introducing at the fourth position of already existing chiral center. Is one that is 1,4 asymmetric induction. Okay, new chiral center is introducing it fourth position of already existing chiral center is 1,4 asymmetric induction. Now this is the 1,4 chiral. This is a confirmation of Prelong's rule. Is that according to Prelong's rules? When keto ester and keto carbonyl ester carbonyl are anti to each other. Keto carbonyl ester carbonyl are anti to each other. At chiral center, large group at in plane. At chiral center, large group at in plane. And keto carbonyl ester carbonyl large group chiral center must be in plane. And at chiral center, medium and small groups are out of plane. That chiral center, medium and large group are out of plane. And the nucleophile attacking at keto carbonyl. The nucleophile attacking at keto carbonyl from the side of small group side. from the side of small group side. Okay, this is a conformation. This is a pre-Long's conformation. What is a pre-Long conformation? That keto ester and carbonyl keto carbonyl and ester carbonyl must be anti to each other, and large group at chiral center in plane. Keto carbonyl ester carbonyl large group at chiral center is on one plane, and small group and medium groups are out of plane. And the addition of nucleophile to the carbonyl ketone from the side of small group, from the side of small group. Okay, when we added a nucleophile RMGX, when we added nucleophile, the nucleophile approaching from small group side. Here in the chiral center, small group is front face, okay, or top face. Okay, that nucleophile approaches the keto carbonyl from top face only. Okay, then hydroxy going to back side. Here R dash, and large, medium, and small. After hydrolysis, the bond is breaking. They forms a chiral center. They forms a chiral center. This is the compound. Okay, this is a pre-Long's rules. Okay, pre-Long's rule applicable for 1,4 asymmetric induction. Next, we are going to discussing asymmetric Diels-Alder reaction. Diels-Alder asymmetric Diels-Alder reaction. Asymmetric Diels-Alder reaction. For this asymmetric Diels-Alder reaction, we are take minus menthol. Minus menthol is taken as a chiral auxiliary. That minus menthol structure is, this is a minus menthol, CH3, and here OH. This is a minus menthol. This is a minus menthol, and conformation structure of this minus menthol is conformation structure. And Diels-Alder reaction. For this Diels-Alder reaction, we are take dienophile. Dienophile is, this is a dienophile. This is a dienophile. This ester and what alcohol reacting with, they forms another ester. Then forms another ester. They forms another ester. Then forms another ester. Hydrogen, here hydrogen, double bond, O. This diisopropyl and methyl. Okay, when we take diene, when we take a dienophile, this dienophile approaches from top side only. The dienophile approaches from top side only. Then the corresponding compound is, R and R. This is a formation takes place. Okay, this is a compound. Okay, to our important topics are that is first one is very important topics are. First one is alkylation of chiral azinolates and alkylation of chiral enolates. Very important is alkylation of chiral enolates and alkylation of chiral hydrogens and alkylation of chiral amines, pre-long suits are very, very important. Okay, thank you.